One lab to go. In this lab, we're going to build a battle between humans and zombies. We will start by building a zombie class. They have life points. They can be shot with the take hit method, and they can recover some of their life points. The tests for these functions are given to you, but here are my clues. For take hit, the parameter is the maximum hit they could take, but there's a random effect. The damage they actually take is anywhere from 0 to that max hit value. We did random numbers in stage 2. Feel free to review if you need to. For recover, the rule is that they recover 10% of the life points they are currently missing. That means you'll have to add an instance variable that remembers their original life points, and then their recovery is 10% of the difference between that original value and their current life points. After you get that working, we realize that we want to make a human class, and it shares the life points functionality, the life points instance variable, its getter, and the take hit method. But humans cannot recover, so they don't need original life points or the recover method. So we're going to refactor the code to put the common stuff in a life form class and leave the zombie specific stuff to zombie. Then we're going to make a zombie and a new human class inherit from life form. When our classes inherit functionality, we need our tests to inherit in the same way. So we structure our tests the same way we structure our production code. The tests that test common functionality will be in the parent class, and the tests that are specific to either human or zombie will be in test human or test zombie. The tests in test life form will be inherited into test human and test zombie. When they're in test human, we want them to run on a human object, and when they're in test zombie, we want them to run on a zombie object. Let's look at an example. Test hits hurt randomly gets inherited into both test human and test zombie. As it was originally written, the object that it tests is dead Fred, and we create that object with new zombie. When that gets inherited into test human, it'll still be testing on a zombie object. That's not what we want. So we need to change how we create the object. We need a way to create a human when we are testing humans and a zombie when we're testing zombies. To do that, we're going to make a method named createLifeForm that returns the object that we want to test. In testLifeForm, we replace the call on a new zombie in our test with a call on createLifeForm. So this is what that looks like. CreateLifeForm is abstract in the parent class, and in each child class, the code will build the right type for that class. The implementation in testHuman will build a human, and the implementation in testZombie will build a zombie. So when we run testZombie, test hits hurt randomly gets inherited into testZombie, so it gets run. When it calls createLifeForm, it will use the one in the testZombie class, which makes it create a zombie object for the test to use. With this solution, we're taking advantage of a technique called polymorphism, when an object's type is declared to be the superclass, but the object's actual type is the subclass. Our variable, deadFred, is declared to be of type lifeform, but when the test is running in testZombie, he's a zombie, and when the test is running in testHuman, he's a human. This works because inheritance is an is-a relationship. A human is a life form, so it's okay that deadFred is declared as a life form when he's really a human. One thing to notice, when we declare that createLifeForm is abstract in testLifeForm, we're essentially deferring the implementation to the subclasses. Since its implementation is incomplete, the test lifeform must also be marked as abstract. The same thing happens with the class lifeform in our production code, so lifeform is also abstract. When a class is abstract, you cannot create instances of it, so you cannot say new lifeform. This also means that you cannot run test lifeform directly. Eclipse won't give you an option to run it, and if you force it, you'll get a message saying no tests found. The only way to run those tests is to run test human or test zombie, where they will be inherited, and that will make them run. Just one more definition. What we are doing with create lifeform is called overriding. That's when we create a method in a subclass that replaces a method we would inherit from the superclass. We've been overriding methods for most of this class, every time that we built a toString method. Remember, the default implementation gave us that ugly output. Well, that ugly output was from the method that we inherit from the class object, that all classes inherit from by default. When we build our own toString method, we are overriding the ugly one with one that is nice for our class. That's it. We're finished, and you've learned a lot about how to program in Java. Check out my other playlists for more fun coding stuff.